So you've got 3 different versions. Competitive, you can have 2 things come into this active site.
Substrate or the inhibitor.
I don't know why I did concentration, but substrate or inhibitor.
And then uncompetitive, you have 2. Oh my gosh, what's open spots that at binding sites.
Mm-hmm. And so which one has to bind first?
Substrate.
Substrate binds first. And then mixed.
Is the same, but you can.
Yeah, it's special because you get that same thing. But either can bind first. So.
And basically the inhibitor works because it changes the
Conformation of the enzyme can't really work
Yeah.
when it has that inhibitor in there.
Okay.
It'd be like trying to fit something into a moving engine.
Okay.
Mess it up on your car, make it stop working if you plugged all of the cylinders up. So do you understand the Lineweaver-Burke equation and how it applies to this?
Yes.
And the graph, you understand that?
Yeah.
Okay. What was it that you didn't get about these?
I just get them confused. I just get them mixed up sometimes.
Okay. So just make sure you memorize this.
Yeah.
That's important.
I think I was just up late last night talking about
Yeah.
it to a friend, and I was like, I can't get this in my mind.
Now, do you understand why they affect Km and Vmax?
So
Like why which ones do what they do?
some uncompetitive affects both, and then mixed can
Affect
affect both too. But
Competitive doesn't know. Why? Do you know why?
competitive, I don't know why.
Okay. That's something that's worth understanding, and so we'll just discuss it really quickly. If you look at the graph on there, as we get towards the
I remember
y-axis,
talking about it yesterday, but I can't remember.
let's just pretend those all intersect at the same point. So that's the Km. We know that when I do that, that's 1 over V naught, and this is 1 over substrate concentration. Now what do these 3 lines represent?
Slope.
They're not slope, they represent something in the experiment.
Oh,
Mm,
it's
I think it's that way. Yeah, it's
The reaction, rate of reaction.
concentration of inhibitor.
No.
So what we see is, remember, the further we get away from the 0 point, the smaller we get. So as we go there, we're going down. As we go out here, we're going down. So if we look at this, at this point, this guy has the most inhibitor. This is the one with the most inhibitor. Now, at this point, he's closer than, well, I guess that's not really what I want to talk about, so I won't. What we can see right here is, look at this slope. See how steep it is?
Mm-hmm.
This means it takes a very, very high concentration for him to even be in this same area. His velocity is so slow compared to this velocity, and this is the fastest velocity.
okay.
But because substrate and inhibitor compete for the same spot, here, inhibitor is a constant. On this line it's a constant, on this line it's a different constant, and on this line it's a different constant. So here it's like 5, here it's 3, here it's 1.
Mm-hmm.
But substrate is a variable. As we increase substrate concentration, as we get closer to 0, you're essentially getting closer to infinity. Or to just an unlimited number amount of substrate concentration. So, once you get to that point, there's such little inhibitor compared to substrate that you will all have the same Vmax. Because it doesn't matter if you've got 3 beakers, you've got 1 inhibitor, 3 inhibitors, or 5, when there's, 1 times 10 to the 36 concentration of substrate. Doesn't matter if that's in here or if it's in here, they beat out the inhibitor hands down. So that's why
Oh,
Vmax
yes.
isn't changed.
Yeah, I do remember him saying that.
You put it as a KM instead of Vmax, but yeah.
Oh,
1 over
thank you.
Vmax.
Yeah.
And
you for that
it's
correction.
The negative 1 over KMs.
Yeah, it's over here. Those
So-
are here.
KM changes, just Vmax doesn't.
Mm-hmm.
Okay.
KM is binding affinity, and it can be affected because, it can bind in there, so it
Yeah.
can actually slow it down.